All right, guys, we're looking at number 15. You've got a small pond that contains 7 catfish and 6 bluegill. If 7 fish are caught at random, what is the probability that exactly 5 catfish have been caught? So what I'm going to do is I'm going to underline catfish in red. I'll underline my bluegill in blue, and I'm going to say we'll say that C means catfish, right? Just for the purpose of demonstrating what's going on here. And then B will represent a bluegill. So what's happening is we're told that we're out of 7 total fish caught, 5 of them are catfish. We're not told this directly, but of course that implies, if there are 7 total and 5 are catfish, it implies that the other 2 were bluegills, right? The first thing to think about here, for me anyway, is that I could catch catfish, 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 and then my bluegills after. But there's nothing saying that they have to be caught in that order. I could also catch 4 catfish, then 2 bluegills, and then finally the 5th catfish, right? Still 7 fish. But then there's also this possibility that I could catch 3 catfish, then the 2 bluegills, and then 2 more catfish. And you can probably see this pattern that's going to show up. And then someone's going to say, well, what says there's nothing telling us that the 2 bluegills have to be caught together, blah, 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 blah. We've got so many different possibilities here. So it's probably a smarter idea for us to use counting theory. So we're going to use counting theory to figure out how many different ways we could catch those 5 catfish and 2 bluegills. So it's a group of 7. So I'm going to say, hey, I've got 7, and I want to choose from them, it's a combination, a group of 5 catfish. So how many different ways can I get a group of 7 that contains 5 catfish, right? So here's my 5 catfish. Of course, from our studies, you guys probably remember that this is actually equal to having a group of 7 and choosing 2. That would be if we looked at just the ways to choose 2 bluegills in that group of 7. These numbers will be equal. So if I were to write out the problem, how many ways to do that, this one right over here would be 7 times 6 times 5 times 4 times 3, 1, 2, 3, 4, 5 over 5 factorial. And this one would be 7 times 6 over 2 factorial. Now, you can do that math, use a calculator, whatever you want to do, just to verify that they're equal. But, of course, they are, and that number is 21. Right? So there are 21 different ways to catch this group of 7 fish where 5 are catfish and 2 are bluegills. Now, that doesn't give us probability. It just gives us the number of ways to do that. So whatever I get for my probability, I'm going to multiply it by 21. Right? So 21 times, if I did one of these, right, then I could figure the rest out. So what's the probability that first fish is a catfish? Well, there's 7 catfish out of, 13 total fish. Once I've caught one of the catfish, there are only 6 left. But nothing up here says I threw any of the fish back, which means I'm keeping them for whatever reason. So it's 6 out of 12. Then there's only 5 catfish left out of 11. 4 out of 10. That's 1, 2, 3, 4 catfish. And now that 5th catfish, there's only 3 left out of 9. I'm done catching my catfish, but I still have my bluegills, of which there are 6 out of 8 total fish in the pond, then 5 out of 7 total fish in the pond, right? So this piece right here that I just did, this is actually this guy right there, right? It's actually that line. Now, this 21, remember that 21 is accounting for all the different ways that I could line up this 5 catfish, 2 bluegill combo. If you compute all of this, right, multiply the numerators, multiply the denominators, multiply the whole thing by 21, you'll find that you actually get that answer of 105 over 572.